Okay, the next major concept that we run into that we need to do math often in the lab is instead of going in the lab and doing a practice like the last problem where we need to go weigh out solid sodium hydroxide and we're going to dissolve that in water, get it all dissolved, bring the total volume up to that 1.5 liters such that in the end it's going to be 2 molar. That would be going in and getting a solid reagent to dissolve in water. Another very common thing is that we go into the lab and we use a more concentrated solution to prepare a more dilute solution. So instead of starting with a solid, we start with a more concentrated solution than we actually want. That process is simply diluting that concentrated solution, but diluting it to the right amount, such that in the end, we have the concentration we actually need. Lucky for you, this can be done by plugging and chugging through this equation, which just simply sets you up to have the right number of moles of solute in the portion of the concentrated. So you're going to pull this from the concentrated solution. So you're going to take a pipette, for instance, and pull out 10 mils, 15 mils, 20 mils. In that sample that you pull out of the concentrated solution, you're going to take that, you're going to put it into a new flask, and you're going to add water to it. But the whole idea is that number of moles of solute did not change. So it is equal to the same number of moles of solute in the dilute solution. What's the difference? The amount of water. If you have more water in the dilute solution, it will have a lower concentration. And that is the whole idea of doing molarity times volume equals molarity times volume, because that is moles per liter times liters on both sides. Moles per liter times liters. So what cancels is liters. And you're saying moles in the concentrated sample is the same number of moles as is in the dilute sample. All right, let's do a quick sample problem here. It says if 35 mils of 2.5 molar sodium hydroxide is diluted, so this one's screaming at you that it's a dilution problem. It's actually using the word in the problem, to a total new volume of 100 mils with distilled water. It should be distilled water, deionized water, same thing for our purposes. What will the molar concentration of the new solution be? So there's your question, the new concentration. So this is going to be V1, your 35.00 milliliters, the volume of the concentrated. And this is going to be M1, the molarity of that same concentrated solution. V2, the volume after dilution, will be the 100.00 mils. And then it is M2 that you're solving for. So M1V1 is equal to M2V2. Oh, that's going to be 2.50 molar times 35.00 milliliters. So M2 is what you're solving for, and the new volume is 100.0 milliliters. Now, if you plug and chug through that, you're going to get M sub 2 is equal to 0.875. And 3 sig figs again, because if you look at all of your numbers, the 2.50 is only 3 sig figs. So that's what's limiting sig figs in your answer to 3.